Right now, you're standing on a handful of things you have never once questioned: that the ground is solid, that your atoms will keep their shape, that the rules holding all of it together will still be the rules 1 second from now. Out in the universe, there are places where every single one of those turns out to be false. We like to picture the cosmos as full of dangerous things, as if the danger were something out there, something you could keep your distance from. It's stranger than that. The most terrifying places don't just threaten what's inside them, they quietly reveal that nothing you're standing on was ever guaranteed. So the real question isn't how dangerous the universe is, it's how much of what you call permanent was only ever borrowed. But before we go anywhere out there, look at where you're standing right now. The air holds still. The ground stays solid. Your atoms keep their shape without ever being asked. It feels permanent, fixed, guaranteed. Not one of those 3 words is actually true. They're just quiet here, for now. Imagine the whole universe shrunk down to a single ocean. Every galaxy, every star, all of it poured into that one body of water. Everywhere calm enough that matter stays gentle, that light behaves, that the rules keep their word. That would be a thin film shimmering on the surface, a skin of the reliable, floating on an ocean where none of it is promised. By the end, we'll reach a place that puts the very last of those certainties, the rules themselves, in question. And it leaves you with something that has no comfortable answer. How much of permanent was ever real? So let's go down, one certainty at a time. We start close, with a dead star. When a giant star runs out of fuel, it collapses into a core the size of a city, but heavier than our entire sun. A single spoonful would weigh about as much as Mount Everest. Most of these are called neutron stars. A few of them are wrapped in something worse, a magnetar. And here is the certainty it quietly removes. Every magnet you have ever touched, you could win against. Pull it off the fridge, pull your hand away, push, and matter pushes back. Its shape holds. That is the deal you have had with matter your whole life. The magnetar does not honor it. Its magnetic field is around 1,000 trillion times stronger than Earth's, and it would never need to touch a thing to change it. Even from around 1,000 kilometers away, its field reaches into matter and pulls the atoms out of shape, stretches them into thin, useless needles. Not by burning, not by crushing, but by unwriting the chemistry that anything solid is built from. In 2004, a magnetar called SGR 180620 flared for a fifth of a second. In that fifth of a second, it released more energy than our sun gives off in 250,000 years. It compressed the magnetic field of our entire planet from 50,000 light-years away on the far side of the galaxy, from an object the size of a town. So the first thing we take as fixed, that matter keeps its shape, turns out to have a distance at which it simply doesn't. One certainty down. How many of the things you never think about are like this? Solid, right up until they're not. A magnetar is still a thing, a place with a surface that you could, in principle, keep away from. The next certainty doesn't break at a surface, it breaks at a line. Your whole life, everything has run both ways. Light bounces back so you can see. Every step you take, you could turn around and retrace. There is always a way back. Every black hole has a line where that stops being true. Cross it, and no path leads out again. Not for a ship, not for light, not for anything. We call it the event horizon. Anything that falls toward one gets stretched, slowly, and then not slowly, into a thin stream of itself. Atom pulled from atom. Physicists actually have a word for it. They call it spaghettification, the most relaxed possible name for the most violent thing gravity can do to matter. And from the outside, you would never even see it finish. You'd watch it slow and redden and dim and hang there at the very edge, fading forever. Because the light that would tell you it was gone can't get back out either. You'd assume a thing like that is dark, but a black hole is only dark when it's starving. Feed one. Pour in gas, dust, whole shredded stars, and it turns into something monstrous. The doomed matter spirals in, tears itself apart, heats to millions of degrees, and screams out light across the entire universe. We call that a quasar. The brightest one we have ever found has a name, JO 5294351. Its core swallows a whole sun's worth of matter every single day. It burns 500 trillion times brighter than our sun. It outshines its entire galaxy, hundreds of billions of stars, so completely that for decades we mistook it for a single dim point of light. The darkest object in the universe is also the brightest thing in it. Bigger should mean more violent. It means the opposite. The one at the center of our own galaxy is 4 million times the mass of the sun. Others are so enormous that you could pass the event horizon without a sound, without a jolt, without any warning that you'd crossed the point of no return. We don't even agree which one is the largest. We only know we haven't found the biggest yet. Two certainties gone now: the shape of matter and the way back. And both were still things, sitting somewhere that you could point to. The next one you can't point to at all, because it's already happening to you. Sit still for a second. The room is still. The ground under your feet hasn't moved in your whole life. Earth feels about as fixed as a thing can be. It isn't. Right now, the entire Milky Way, you, everyone you love, every human who has ever lived, is being pulled through space at around 600 kilometers every second, toward something. And for decades we could not see what, because it lies in the one direction we can't look, straight through the crowded, dusty disk of our own galaxy, a region astronomers call the zone of avoidance. Something enormous is on the far side of our own light, and our own galaxy is standing in the way. We named the pull the Great Attractor. We now think it isn't one thing at all: a nearer wall of galaxies, a far larger mass hiding behind it, and, strangely, a vast emptiness on the opposite side that seems to be pushing us away. Pulled and pushed at once, at a speed you cannot feel and cannot stop. So the stillness you're sitting in right now is the third thing that was never real. You are moving. You have always been moving at 600 kilometers a second, and you cannot feel a single part of it. And the thing with the grip to drag an entire galaxy is still sitting behind our own light, unseen. We can measure exactly how hard it pulls. We still can't say for certain what it is. Look up on a clear night, and space looks crowded. Stars everywhere. Every deep image the telescopes send back is packed edge to edge with galaxies. Everything you can see says the universe is full. Its most common feature is emptiness. Scatter the galaxies across the cosmos, and they don't spread out evenly. They gather into glowing threads and walls, with dark gaps between them. Most of those gaps are ordinary. One of them is not. It's called the Booty's Void, the Great Nothing, a bubble of near-total emptiness, roughly 330 million light-years across. A region that size should hold around 2,000 galaxies. We have found about 60, and here is the part that reaches in. One astronomer put it like this: if our galaxy sat at the center of that void, we would not have discovered that other galaxies existed until the 1960s. We'd have looked up for our entire history and seen a handful of stars, and then dark. We'd have believed we were everything, with no way to know we weren't. And Booty's isn't even the largest. Further out lies the Eridanus supervoid, a stretch of barely filled space nearly 1.8 billion light-years wide. It sits in the same direction as the single coldest patch of the entire sky, a cold spot our best theory of the universe still cannot fully explain. A hole so big, we're not even sure why it's there. So the fourth thing goes too, that space is full. We found the emptiness, and then a bigger emptiness we can't account for. And past even that, there's a place where the one thing we have left, the ability to look at all, quietly runs out. Give us a big enough telescope, and we assume we could always look further, a little deeper, a little older, a little closer to the beginning, as if seeing had no limit, only a budget. But there is a limit, and it's moving the wrong way. There's a distance beyond which light simply hasn't reached us yet, and because the universe is expanding, and that expansion is speeding up, some of that light never will. Right now, galaxies are crossing that line, not dying, not moving away in any ordinary sense, just slipping past the edge of anything we could ever see, or signal, or reach, carried off by the stretching of space itself, faster than light can close the gap. Every single day, the universe we can observe holds a little less. The knowable isn't fixed, it's shrinking. You'd think that's the bottom, the point where even seeing gives up. It isn't. There's one certainty underneath all the others, the one that has been holding every place on this list together, and it's the one we can't promise at all. Everything so far has taken away a thing. The shape of matter, the way back, our stillness, the fullness of space, the reach of what we can know. This last one doesn't take a thing. It takes the rules that make things things at all. Empty space might not be truly empty, or truly stable. When physicists measured the Higgs field, the numbers came back unsettling. They hint that our universe may be sitting in what's called a false vacuum, a state that feels stable, that has felt stable for nearly 14 billion years, but that might only be resting in a dip, with a deeper, lower state waiting just underneath. If, anywhere, at any moment, one tiny patch ever slipped into that lower state, a bubble would form, and it would expand outward at nearly the speed of light, rewriting reality as it went. Inside it, the constants of nature would change. Atoms wouldn't hold, chemistry wouldn't exist. Light itself might not work the way it does now. Not an explosion, not fire, just the rules of existence, quietly swapped for different ones. And everything the old rules ever built, simply gone. And because the bubble moves at the speed of light, nothing could see it coming. No flash, no warning, no moment to understand. One instant before, everything is exactly as permanent as it feels to you right now. Now, breathe. Most physicists think this is extraordinarily unlikely, on any timescale that could ever matter, and there is no evidence at all that it's coming. If our vacuum can decay, the wait could be longer than the current age of the universe raised to staggering powers. It is a maybe, a shadow at the very edge of our best equations. But that maybe is the whole point. Every place before this took away something we counted on. This one takes the last thing, the quiet certainty that the rules themselves are fixed. And the honest answer, from the people who understand it best, is that they cannot promise you they are. Let's stop here, at the bottom, and look back up at everything we've taken apart. The magnetar took the shape of matter. The black hole took the way back. The attractor took our stillness. The void took the fullness of space. The edge took the whole of the knowable. The bubble takes the rules themselves. One by one, everything we called permanent turned out to be local, temporary, on loan. So why does the ground feel solid under your feet right now? Why do the atoms hold, and the light behave, and the rules keep their word? Not because any of it is guaranteed, because you happen to be standing in the one thin place where all of it holds at once. A quiet, local truce between forces that keep none of their promises anywhere else. You have spent your whole life inside that truce, mistaking it for the floor. And the most terrifying thing in the universe was never a place you could visit. It's the word permanent, a word we invented for things that were only ever on loan. So look up tonight. The ground holds. The atoms hold. The rules hold. They held yesterday, and the day before, and every day of the 14 billion before that. And you will almost certainly never see the day they don't. Our universe that could unmake every one of these certainties, and for now, simply doesn't. Not because it's gentle, just because here, in this one thin place, the lone hasn't been called. There is one more. We've traveled billions of light years, chasing the places where permanence breaks. But what is sitting one step away the whole time? Venus is almost Earth's twin, nearly the same size, nearly the same mass, born right beside us from the same cloud at the same moment. For a while, the two of them may have looked almost the same. And then, on time, the conditions that keep a world gentle just stopped. Now the air would crush a submarine, the heat would melt lead, and it rains sulfuric acid that boils away before it ever touches the ground. Two planets born together. On one, permanence held. On the other, it didn't. And nobody fully knows why we were the one it held for. The universe doesn't need monsters at its edge to make the point. Sometimes it only needs to show you your own twin, one step away, and let you feel, just for a second, how thin the ground really is. But for now, it's still solid, still here, still breathing, still looking up. There is more to explore. See you beyond the stars.